big but is careful with 0. Please, please, please be careful with 0. Now you know that 0 is a total mess when it's in fractions. Not if 0 is on the top. That's not a mess. What's the answer to that? 0. But 0 is a total mess if it's on the bottom. What's the answer to that? Math error or undefined. You might think that anything divided by itself is 1, not 0 over 0. That's math error too. 0 on the bottom of anything is total math error, total disaster. So this raises the question, in what ways can cot theta be stuffed up? In what ways can cot theta get a math error? Well, I'll write literally what it is. Cot theta is 1 over sine theta cos theta. So, Ellen, what you saying? Yeah, if sine is 0, this is all messed up. Yeah? Because this fraction here will be 0. Because its numerator will be 0. And a numerator being 0 often makes a fraction 0. But that's no good because then you'll be trying to divide it into the number 1. So this is all messed up if sine theta is 0. When else is it messed up? If cos theta is 0, it is directly messed up if cos theta is 0 because then you'll have a 0 underneath this little mini fraction. So this is all messed up if sine theta or cos theta are 0. In other words, it's messed up there, it's messed up there, it's messed up there, it's messed up there. There are 4 positions on that diagram where cot theta is messed up. Does that make sense, Emily? What about this though? Where does that get messed up? I mean this. Only one thing messes that up. The only thing that messes that up is sine theta being 0, I think. It's fine with cos theta being 0. So therefore, this is a great little rule of thumb as long as you're not talking about zeros. But it's not quite the same because this is all messed up there, there, there and there, whereas this is only messed up there and there. No, wait on. There and there. In other words, where sine theta is 0. Does that make sense? So let me just tell you what the graph of this guy looks like. This is graph of y equals cot theta. Okay, right. Now it also looks like the tan graph. The tan graph looks like the snake. But what's the difference between the genuine snake and tan? Anyone know? Looks like a whole bunch of snakes, but there's 2 differences. You know what I mean by a snake, right? That's the cos graph. Yeah, that's the cos graph. So that's the cube graph. What's the difference between the cubic graph and the tan x graph? Yeah, it repeats. It's got asymptotes. Yeah, and it got loads of them bounded within the asymptotes. So it's got one there, it's got one there, but there's another difference in the shape. It looks like a snake, but what is it? What's the difference? Anyone remember? Should have learned it in core 2, Rebecca? That fella is genuinely flat there. When you draw y equals x cubed properly, you have to make him look flat there, right? It's not the case with tan x. When you draw tan x, you have to make him look properly steep. Yeah, not flat. So anyway, this is the graph of cot x. It's just tan x the other way around. Yeah? The asymptotes are still the same, I think. Are they though? That's 90, right? That's 270. So would 90 be an asymptote for cot theta? Cot theta is cos theta over sine theta. So that will be absolutely massive whenever What will make that massive? That will be massive if sine theta is little and cos theta is decently chunky. So where's an example where sine theta is little but cos theta is decently chunky? No, I disagree. Isn't it at 0? So this is the cos graph, right? I'm right, aren't I? And here in red is the sine graph. So what leads a graph to be astronomically high? It's when the numerator is decent, like 1 or 2, and the denominator is absolutely tiny. So where is an example like that? Isn't it here? That's where the numerator is decently chunky, like it's about 0.99, but the sine graph is tiny, so 0.99 divided by 0.1 will be like 100. So I think the asymptote is not where I've marked them. I think it's here. Is that right? Yeah? Say again? Okay. Now what about... So where's the other asymptote? 180, I think. Yeah? So this blue fella that I was starting is wrong. So there's a super low asymptote there. Let's just convince ourselves that that's right. Out near 180, we have very decently negative cos graph, like negative 0.99. Divide that by tiny sine graph, like 0.01. You get like negative hundreds. That's why it's so low, right? So Emily and Emma, is that looking what the textbook says? Yeah. Now, can I ask you, does the text, and it's over here, right?
Yeah.
So, like the sine and cos graph, it's got something interesting every 90 degrees, right?